Okay, folks, we do need your attention. Thank you. All right, so the first question here talks about domain, and it wants you to find the range. Now, what does domain mean? Inputs, very good, the set of all the inputs. Range is the set of all the outputs. So what I need to do is plug in each of those elements of the domain and get the elements of the range. And for some reason, the numbers on this are different. I guess I used different numbers one year, and then I did on this year, and I guess I didn't save it. So let me first change this to, I think this should be y equals negative 5x minus 1. Am I right about that?
Yeah.
Okay, good. So here's my domain, and let's plug it in and see what we get. So what's negative 5 times negative 3?
15.
15. And what's 15 minus 1?
14.
14. So that would be the first answer. You should have the squiggle there. I didn't take off points if you didn't. Let's plug in a negative 2. What's negative 5 times negative 2?
10.
10 minus 1?
9.
9. Good. Let's plug in a negative 1. What's negative 5 times negative 1?
5.
5 minus 1?
4.
4. I can see a pattern beginning to form. My favorite. What's,
0.
even Figurowski can do this one. What's negative 5 times 0?
Oh.
0. Very good. Minus 1. She looks for her calculator. Negative 1.
Right here.
I know, but when I asked you that question, you went like this.
No, I looked at my paper.
Oh, paper. Okay.
Why did
All
you
right.
have to look at the paper?
We have to build up Kelly's confidence in herself. You want to know what I don't understand? Can just between us girls. Can I tell you? Are you ready? I don't understand how you could stand up in front of thousands of people you don't know and go, "Oh, say can you?" And then you get negative 5 times 0. You're like, looking all over the place. All right, so let's go to negative 5 times 1. What's negative 5 times 1? Negative 5. No, anything times 1 is itself. Now go down another 1. Negative 5 minus 1? Good. And now let's plug in a 2. Negative 5 times 2? Minus 1? Negative 11. So that's how we generate the range. Okay? Now, Ms. Torres, head in the game. So here's the deal. Is it possible for you to get that question wrong? Yeah, absolutely. You know, we have talked a lot about domain and range. And that is something I feel I've covered very well, and that you should be able to get right. But these quizzes form multiple purposes. And one of the things that I find really important about this quiz, and all the quizzes I give, I have a tendency, a weakness, well, sometimes it's a strength, sometimes it's a weakness as a teacher. I like to not do just math all the time. And a lot of kids really appreciate that, but some kids don't. And I like to weave in life stories and kind of fit it all together, like I did a few minutes ago with those who read about history and those who actually write history. Yeah, there's a big difference between the two. And I sometimes can get so distracted by that stuff that I forget to emphasize certain points. So these quizzes represent what the state is going to give you on the Regents exam over and over and over again. So by taking these quizzes and repeating them each day, I make sure that those important topics are covered thoroughly so that you can get them right. Okay? Now, here is the range. The range is the set of outputs. We've put them all together. We should be in good shape. Is everybody good on that? Okay, excellent. Now, let's scroll the paper up a little bit. And again, I don't know why these numbers are not the same, but we will adjust them and get this going. Okay, so this says negative 3, negative 1. Rate of change is 3, starting at the point negative 3, negative 5. Negative 1 to 1, starting at the point negative 1, 0. Rate of change negative 0.5. 1 to 6, starting where you left off. Rate of change is 1/2. And then 6 to 8, starting at 6.5, rate of change is 0. Okay, so now, this was the part of the quiz that gave everybody a hard time or a more difficult time. Now, one of the great things about these quizzes, in addition to the fact that it pulls me back into what I have to make sure I do, is it lets me know, it's great for you, because it lets you know where you need help. It's great for me, because I can see where maybe the whole class struggled on something. And generally speaking, if that happens, it's normally my fault. It's not normally your fault. For instance, if on number one, we had 20 people take the quiz, and 19 of you got it right, and one of you got it wrong, whose fault is that probably? It's whoever got it wrong's fault, and it's probably just a stupid mistake. But if I give 20 questions, if on question one, only one kid gets it right, who do you think's at fault for the 19 that are getting it wrong? Yeah, that's on me. So I like to use the quizzes to assess from my point of view where I could have been bad, or from your point of view where you need to be better. And then we improve on those things. So, and I really truly don't care whose fault it is. I don't care if it's mine, I don't care if it's yours. I just care that we get it straightened out. That's really what matters. So, the next thing about this that seems strange to me is that there wasn't a line. You gotta straighten out, but now we're ready to rock. Okay, so here's the part A. We begin at the point -3, -5. 2, 5. There I am. Now, notice as we look at this, we have a bracket and then we have a parenthesis. So the bracket means we're gonna have a solid circle because we can fill it in. The parenthesis means that we won't. So one of the first things I looked for on your paper was which circles were solid and which circles were open, okay? Next, I looked for the rate of change. In this case, the rate of change is 3, which is really 3/1. Remember, rate of change is slope, which is change in y over change in x. So the vertical change is 3. That means we're going up 3, up vertical. And over 1, the horizontal change is 1. So from here, I'm going to go up 3 over 1. But now there's a parenthesis here, which means I need an open circle. So I go up 3 over 1 again, and I connect the dot. So I basically made that little segment worth 20 points, and I looked to see, did you have a solid circle, did you have an open circle, did you do the slope the right way? Next, it says from -1 to 1, and notice this is a bracket this time, so it being a bracket means that it's allowed to equal -1, but it says you start at the point -1, 0. So you're gonna go there. So I am beginning to think that I didn't teach something well enough, because on this one, and also on something coming up on the quiz, there was a bit of a problem. And when I get to the two of them, I'm gonna take a moment to go back and really emphasize what either I didn't make clear or I didn't perhaps even say at all. I might have done a little too much assuming. Now, the rate of change is -1/2, and I am going to go until I hit +1. So it's down 1 over 2, and there's +1. And, this is an open parenthesis here, so this needs to be an open circle. So there's the next piece of the graph. And again, that would have been worth about 20 points. Okay. Mr. Bruno, how are we looking here? Am I doing a better job explaining? Excellent, thank you so much. Now, this is where it gets a little bit weird. First off, double brackets here and here, so that means solid circles on both ends. And it's gonna go from where I left off, so I'm gonna start here, okay? And then I'm gonna go with a rate of change of +1/2 all the way up to 6. So I'm gonna fill this circle in, then up 1 over 2, up 1 over 2. Now what's kind of weird is that if this was 1, this is 3, 5. If I go up 1 over 2 all the way again, don't I go to 7? And I saw a lot of kids do that on their paper. But it says that you're only supposed to go to 6. So you're gonna go halfway up and stop there. Okay? So that was a big mistake that I saw in a lot of kids' papers. In fact, I think 2 or 3 kids had 95s, and that was the mistake that I saw, more often than not. Okay? Now, the next thing that it says is starting at the point 6,5, and this is an open circle here, ready? Open circle, 6,5, let's see, this is 2, 4, 5, open circle, slope is 0, all the way out to 8. Now, one of the things I think I didn't do a good enough job detailing is this idea of what I'm going to call a jump. I know we did this exact movement on a couple of do-its before we took the quiz. It's really important that you understand that these are piecewise linear graphs, and not every segment has to connect. You can jump in places. So here's a jump, right there. Here is a jump, right here. Certain graphs are best described with a jump. I don't know if you guys have ever gone to New York City, bless you, or other places in a car and you park in what they call a parking garage. Have you ever been in a parking garage? Okay. Now, if you park in a parking garage, what it typically works is that for the first hour you might pay $5. So from the time 0 up until the first hour is done, you pay $5. But anytime you hit the next hour, you're going to pay, say, $7. Then the next hour, you might pay $9. Then the next hour, you might pay $11. And there's a jump here. It's not a gradual change. It's $5, $5, $5, $5, $7. $7, $7, $7, $9, $9, $11. So there are these jumps in graphs, and I know that you haven't seen that very much in other graphs that you've done. But this year we begin to introduce those ideas. When it looks like this, it's actually called a step function because it looks like steps. In this particular case, it's a piecewise linear function, but within that piecewise linear function, you can have jumps. And you just have to pay attention to points where you start, points where you end. Yes? No, the jump is at 6, right here, okay? But it ends at 8. So I went to 6 with the jump, and then I go over to 8, okay? All right, so that's a better idea on your quiz. And what I strongly recommend that you do is you just do your quiz again tonight. If you need to, watch the video when you're home, if it's not all coming to you. Now, if you're getting it right and you're rocking it, don't worry about it. But watch the video again. And we did 3 days of piecewise linear graphs in here. So if you can take this graph and draw it properly, you're in excellent shape as far as your ability to get any of these kind of questions right. All right, so now today's lesson. I think I'm probably a little bit behind where I want to be. I don't know if we have time to do it. Let me see what we got here. 35, and we typically end at 42, yeah. So what I want to do is I want to fast forward into today's lesson, and I would like to first look at number 4. Okay? So on today's Do It, let's take a look at number 4. What would the equation h of t be for an object thrown through the air from a height of 8 feet at an upward velocity of 12 feet per second? Who thinks they got that one right? This was a very important point in class the other day. Okay, so this function, h of t, height of t at any particular point in time, the general form is this: at squared plus bt plus c. A is always either negative 16 or negative 9.8, depending on whether we're doing the English system or the metric system. In this case, since it's talking about feet, what system are we doing? English. So it's going to be h of t equals negative 16 t squared. Now this b here, this is always the upward velocity. Always the upward velocity. So in this problem, what's the upward velocity? All you got to do is read it.
12 feet per second.
Good. So I'm going to go plus 12 because you're going upward 12 feet per second. And then the last thing, c, is always the initial height. So what is the initial height in this problem?
8 feet.
8 feet. So the answer is h of 12 equals negative 16t squared plus 12t plus 8. Okay? Now I want you to do one a little bit differently here, where the initial height is going to be 18 feet, and we'll say this is 35 feet per second. Go ahead, what's that equation? The initial height is 18 feet, and the upward velocity is 35 feet per second. Okay, Ms. Serrano, what do you think? H of t equals what?
16,
Negative 16, right?
yeah,
T squared, keep going.
plus
35,
T
good,
plus 18.
nice. H of t equals negative 16t squared plus 35t plus 18. Let's just take a quick look at number 5. How would you do number 5?
We don't have it.
Oh, you didn't have that on your paper? Okay. Well, you would just plug them in and so on and so forth. Yeah, for some reason, today's lesson, the numbers are a little bit off. I don't understand why. But it should be scoped out the same way. Now, today's lesson is nothing more than a rehashing of the other day's lesson. And the one thing I wanted to make sure I got through, that the other day I'm not as positive that we got through thoroughly, was this question like number 4 here. Let's go to this. You can find this chart on your paper, right? Okay, let's keep going forward just a little bit. Notice it says the same thing here. B is the upward velocity, C is the distance you start above ground. And then we keep going, and then it says one more try. What is the quadratic equation? H of t for an object thrown through the air at upward velocity, 24 feet per second, height of 8 feet. Does your paper say that?
No.
Look for the box, look just under the box.
Yeah, it doesn't say that.
Yeah, it stops at the next row, that's.
Oh, it's on the top of the next page?
Yeah.
Okay, so go to there and do that.
It's different numbers.
Top of the next page. Same exact kind of idea to reinforce that notion. Okay, Mr. Parker? Go ahead. H of t equals.
Negative 16t to the second power
Good.
plus 21t plus.
Hold on, where are we here?
Yeah,
We
on,
have
it, on our.
Okay, you have 21, so we'll go 21t
Plus 38.
plus 38. So on your paper, this says 38 and 21?
Yeah.
Okay, good. So there you go, perfect. Very, very, very well done. Now, the next thing I want to do is talk just a little, by the way, are there any questions about that? We're all good? All right. So, I feel better now because I didn't think I did a particularly good job of getting through that the other day, and now we've done that. So, let's talk about taking it a step further, and it says, plot a graphical representation in the change of elevation over time for the following graphic story. It's a video of a man jumping 36 feet above the ground into a pool of water that's 1 foot deep. Now, I wish, if you go home and you just type this into your browser, you will get this video to watch on YouTube. And it's pretty cool because it's a big guy. He's got to be like a 280-pound guy. And he dives off a diving board into a foot of water.
What?
Yeah, he does belly flop. Yeah, he doesn't go head first. That would be death. But he does a belly flop and he hits, and you can see the parabola of the guy jumping off of the thing. So it's pretty cool. Now, if we turn around and we plug these numbers in to our calculator, we can generate a series of heights. And the graph would look ta-da, like that. All right, hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot. Ciao, arrivederci, adios amigos y amigas. Cheerio.